should look good. And then we'll just open up some questions. I'll give you the answer key, and then we'll get into new stuff. That's my plan anyway. So every time we have a quiz or a test, you can actually run all your formula sheets, whatever you want. If you lost points on your old formula sheets, you should probably rewrite them, because you'll keep losing the same points. That'd be dumb. So this one's all about probabilities. One of the first ones we got was this dude here. Or is basically what? Or is basically add them up, right? Or is basically add. And is basically multiply. All right, I like it. These are kind of good little outlines of ideas to have in your head to make sure you're doing the right thing at the right time. Do you always use the formulas? Is it always a good idea to use them? No. You don't hear math people say that very much, do you? Because normally you're in a course where that's the only way to do shit, is to use the formulas. But probability, the basic idea of probability is very simple. It's all about counting. So I can count everything. Screw the formulas, right? They are complicated because they have to cover every possibility. That's why formulas in general are kind of gross looking. Because there's supposed to be one thing that covers everything that could happen. Holy shit. So in certain situations, there are easier ways to do things. I like it. So probably A or B, though. Officially, the formula is probably A plus probably B minus. Yeah, because you've got to subtract off anybody you counted twice. You count all the A's, you count all the B's, you counted everybody in both twice. But then it's not fair. Okay, I like it. Then we got probably A given B. What goes on the bottom?
B.
The probability of B.
And then A and B.
Yeah. If B happened, the only way A could also happen is if it's in B. So that's the chances you get A is A and B. Freaky shit. And remember, I really want you to remember this. We did problems and then developed formulas based on what we did. So we didn't even know the formulas when we did some early problems, right? Now, you know I'm going to give you problems where you have to use the formulas, but if you got everything you need to count, it's better to not even use them. Some of you guys aren't listening to me. You've got formulas you can plug shit into, you're happy. And you're going to use them wrong, oh well, I can't do much for you. What about this guy?
Probability of
A times B.
A given B or B given A.
B given
Yeah, you have to multiply these two together, but B's chances of it happening might change because A already happened. So that's B given A. Or probability of B times probability of A given B. Either way. They are both equivalent. Let's see, anything else from chapter 3? I think that's it. That's a huge formula sheet. And in fact, you mostly don't want to use this, which is kind of funny. Some of you guys can't handle that statement I just made, but it's the truth about math. There are ideas in math, and there are formulas that capture the general ideas. The ideas themselves might be easier to apply directly. That's why it's better to understand the idea than it is to memorize flipping formulas. That doesn't make any sense. Okay. I like it. Will these be useful on the quiz? Oh shit, yes. Like that last problem on the practice quiz, right? You got nothing that counts. Any other suggestions for formulas before we close the door on this one?
No, because you cannot be mutually exclusive or independent.
Exactly,
right?
those are
You
ideas.
need to know.
You better not put the test for independence on your formula sheet. You better not put the idea of what mutually exclusive is. That's bullshit. It's not the notes sheet. It's the formula sheet. Yeah. Oh, you guys, I love you. I can see in your eyes like, yeah. Say what you want to. All right. Too damn bad. Okay. So that's the formula sheet. That's all you can have on it. Does everybody understand what I just said? All right. I predict about 5% of you at least will have more on it than you're supposed to. My prediction will be true. Unfortunately, I wish it wasn't. I really wish I'd be proven wrong. Okay. I'll leave that for a second. So if you have the practice quiz, and one more copy left, apparently. If you have the practice quiz, remember this side we did in class? We already talked about this side. It's up on the video. Oh shit. Well, just tell me if this guy turns off. I forgot if I made room after this weekend. Let's see how much room is in there. So this side we're going to look at the practice quiz. We can talk about homework questions. We're going to have a little review for the quiz tomorrow, Wednesday. Then I need to get into chapter 4 stuff. Okay. So it's wide open. Whatever you guys want to discuss. If I don't get much questions, I'm just going to get into chapter 4. Yes? Number 2? Okay. So number 2 is the one, I'll leave this up here. I'll leave this up there for people that just came in. Green is not stuff for the formula sheet. I always get somebody like, it was on the board. All right. So number 2 on the practice quiz is the one about the candy bars. There's 7 Twix, 5 Snickers, and 1. Why did I do that? 1 Butterfinger. Okay. What the shit does PTTS mean?
Probability of
Yeah, I really should change the candy bars because once I start talking about this, I always say Twickers or something. I put them together. So this I'm picking 3 candy bars. So this is Twix and then another Twix and then a Snickers. But I'm doing it with replacement. Right, so you'll notice 1A, oh God, Jeff, this is 1A and then there's 2A are the same question. Well, what's different on level 2 there? What's different? Without replacement. So let's do both of these one after the other because they're related. So I'm picking 3 candy bars. How many blank spots do I have? 3. And why is it times in the middle? Because what's the word associated with this problem? And. I want a Twix and another Twix and another Snickers. So what's probably I get a Twix on the first pick? 7 Twix out of 13 candy bars. Right? 13 total. I put that back in. I'm like, I don't want a Twix. Drop it back in. And then I get another Twix.
6.
Careful. This is with replacement. So I dropped it back in. So there's still 7 and it's still 13. I'm like, I still don't want a Twix, man. So I drop it back in because I'm kind of stupid. And then I pick out a Snickers. What's probably I just did that? 5 out of 13. And whatever all that crap comes out to be. All right. I don't know. I'm not going to try to do that in my head. All right, so you just throw that in the calculator, blah, blah, blah. So how does it change for part 2 where it says without replacement? When I get that first Twix, it's still 7 out of 13, but now I eat it.
6 out of 12.
So now I got 1 less Twix, 1 less candy bar, and then what about for Snickers? There's still 5 Snickers. But now there's 11. So when I do it without replacement, what happens to the bottom no matter what? The bottom just goes down by 1 because I'm getting every time I'm picking 1. Don't make the bottom go down by 7. You didn't go, oh, I got 7 Twix. No, you're picking 1 candy bar and then a second one and then a third one. So how could the bottom change by more than 1? Not possible. You take 1 Twix and all the others are like, we're coming with you. No. Maybe. And then you just multiply that shit together. Whatever the hell you get. Is that decent for that problem? I mean, and part B and part C are all the same.
For 2B.
Okay, good. I like it. Let's do it up here. So for B, it's, what was it? Butterfinger, and Twix. So if I do it with replacements, what's probably get a Butterfinger?
113.
1 out of 13, I drop it back in. Now let's probably get a Butterfinger now. Still
113.
1 out of 13, drop it back in. Probably get a Twix.
713.
Still 7 Twix out of 13, I like it. Whatever the hell that is. Now,
Yeah.
you've been so patient. Okay. Down here, where it's without replacement. BBT. Probably get a Butterfinger on the first go is 1 out of 13 and then I eat it.
0.
How is probably get a Butterfinger now?
0.
0 out of 12. Who gives a shit about the next thing? That's 0.
Okay.
It's impossible. If you do it without replacement, you can't get 2 Butterfingers because there's only 1 of them in there.
So you wouldn't go forward and figure out.
You can't.
And then you keep
The next one doesn't make sense. It's because you ran out of Butterfinger on this step. So out of those times that I get a Butterfinger, what's probably get a Twix? That doesn't even make sense because I can't get a Butterfinger on the next one.
Okay,
So if I go down this road, I'm alive. This road, I'm dead. What's probably I'm alive? No, I'm dead. I'm dead. So here, all the Butterfingers are dead. There's no question about what the next one would be. Whatever it is, it's going to come out to be 0. Because you're multiplying by 0 there in the middle. I like it. Does that make sense? So anytime you try to pick more than what you got, it's going to be 0. I like it. Yes. Okay. So for A here. And C. I know. C is the freakiest one. That's the one I expect. That's why I even gave a hint. You're still like, the shit is he talking about? Cleaster God. You understand how this is like a practice sheet? Right? Can you get upset that I put a problem on there that's really weird? No, you cannot. It's impossible for you to do that. You can get upset. Not at me. Right. If I put that on the quiz without any prep work, then you can get upset. I'm not going to do that. Number 4, I tell you just probability. So you have to use formulas here. Oh no, you're dying. Poor little dude. You're so young. Okay, probability of A given B. Now part A says, could A and B be independent? The answer is staring you in the face. If they are independent, what should be true about this and this?
They have to be equal.
They would be equal to each other. Are they?
No.
No. So you say no. Probability of A not equal to probability of A given B. If B happens, does A's probability change? Yes. It goes up a little bit. Okay. I like it. So 0.8 does not equal 0.85. That's the idea there. That's all it takes to say. I like it. B is, could A and B be mutually exclusive? If they're mutually exclusive, what does that mean?
Separate.
So if mutually exclusive, probability of what would equal what?
Of A and B would be 0.
And if A and B is 0, what would A given B have to be? Because what's on the top of it?
0.
This would have to be 0 because it'd be 0 over something. Is that 0? Is that 0? No. So they're not mutually exclusive. If they were, this would be 0, which means anything dependent on this would also be 0. Is that 0? No. I like it. Stop for a second. Yes?
So could your answer there just be probability of A given B is not equal 0?
Yes. I kind of want to see that it's related to this. Because the definition of this involves this. So I kind of need to see that connection, but that really is the most direct reason why. That ain't 0. Why does that matter? Well, because that means that ain't 0, which means that can't be true. Now, part C is freaky shit. Now, so part C says, what's the smallest that could be? I didn't say calculate it. That's part D. What's the smallest that could be? And my hint is look at probability of A or B. What's the probability of A or B? Bush. What's the formula for that? Probability of A plus probability of B.
Minus probability of A and B.
And what's true about any probability you calculate? I don't care what the shit the question is. If it's a probability, it can be at most 1. If it's more than 1 or less than 0, something went wrong. Right? You did something wrong. It's impossible for a probability to be greater than 1 or less than 0. So what's probability of A? 0.8. What's probability of B? 0.4. What's this? I don't know. So this is 0.8 plus 0.4 is 1.2. Now what we just say is true about any probability that we calculate. It has to be at most 1. If that was 0, and remember, we already said it couldn't be 0, but see, if that was 0, the probability of A or B would be 1.2. Is that a problem? Is it a problem if the probability of A or B is 1.2? Yeah, it's a probability. It's not supposed to be more than 1. So what's the smallest this could be to bring this back to legal? 1.2 is how big? How much too big? 0.2 too big. So if that was 0.2, it would bring it back to legal. That's the smallest this could be. It could be 0.3 because then that's still less than 1. That's fine, right? So what's the smallest probably A and B could be? 0.2, because that's what brings this back to legal.
So then you have to work it out and then take it back.
Yeah, you work out to see, well, how much too much do I have? Is there an overlap between the two? Well, add them. If it's more than 1, there's an obvious overlap between the two. Well, how big could that overlap does it have to be? It has to be at least 0.2. I like it. Now that is a freaky ass question. Do you hear me? That's a freaky flippin' question. I just want to put that down there because when you calculate an OR and it comes out bigger than 1, that's normally what you forgot to do, is you forgot to subtract the and piece. Don't just circle 1.7. There you go, Jeff. 170% chance. That is freaky. It's so likely it's going to happen in the next universe. I don't know. What does that mean? I don't know. Okay, all right. So you guys understand? So this is, it's got to be at least 0.2. Why? Because that would bring this back down to making sense. 1.2 doesn't make sense. Then part D, you use a formula, right? Part D is where I ask you to calculate what probability of A and B is. What is the formula for probability of A and B? It's either probability of A times probability of B given A, or it's probability of B times A given B. Well, which one has what you know?
The second one.
Yeah, you don't know this, do you? So screw that one. I'm going to use, because I know this and I know that. I can multiply and get what that is. So it really is. So the first 3 questions here were conceptual questions. On the quiz, I more than likely won't ask as many of those because they can get really freaky really quick. When I ask you, like I give you stuff like this and I ask you to calculate a probability, you write the formula and you step back and you see, did I give you everything you need? If you're missing something, how do I get what I need from what he told me? So here's the formula. That one sucks. This one's better because I know everything I need for that one. Okay. And then part E is easy. Once you know this, part E is write his formula. It's easy. You just got to throw stuff in. You'll start to realize I like to kind of ask you A, B, C, and they kind of build into each other a bit. Yes?
Can you explain 3C?
Oh, okay. All right. I could try. That was our favorite topic.
Last slide.
If there were, all right, let's see. So let's start off easy. If the probability is going to rain today is 0.1, what's probably is not going to rain?
0.9.
Yeah, 1 minus that. All right. So the probability of opposite events, like completely opposite events, right? One is 1 minus the other one. It's something you came in knowing. You knew this already when you came in. When is that not true? It's always flipping true. So if the opposite situation is a probability that's easier to do, I'm going to do that shit and do 1 minus it. Always. Because when is it true? Always true. 1 minus a probability is the opposite probability. All right. What's true about those 2 statements? None, at least one. They are opposites. Why? Because what does none include? 0. What does at least one include? 1, 2, 3, up to whatever, right? So they're opposites because one doesn't have any of what the other one has, and together they're everything. So they are opposites. Is there any other thing that could happen besides rain and not rain? Could any other thing happen? No. Right? What about snow? Well, then that's not rain. So it's one or the other one. So here it's none or it's at least one. So either at least one person in here likes bowling or nobody likes bowling. Is that an incorrect statement? That's a completely correct statement because together that's every possibility. Okay, so look at, before I talk about 3C, look at 3B. Could you guys do 3B? Probably that none, what was it? What did it say again? All 3 dislike the plan. What's another way to say all 3 disliked it? What's another way to say that? All 3 didn't like it, so none of them liked it. That's just English, right? So how many ways is there for none of them to like it? I got 3 people, right? How many ways is there for none of them to like it? 1 way. None of them like it. Right? All right. So there's only going to be one thing I've got to set up here. In order for none of them to like it, what's true about the first guy?
First one didn't like
Doesn't like it. What's probably he doesn't like it?
Didn't like it.
What's probably he doesn't like it?
0.33. Oh, wait, 1. Wait.
The probability
Was it 0.33?
somebody doesn't like it. 0.33.
0.33. Yeah.
You can't get it from what I've written. What's probably the next guy doesn't like it?
0.33.
0.33? I like it. No, 0.33. And you multiply that stuff together. And whatever the hell that is. Right? Okay. What is that?
0.99.
3, 3 times 3, 3 times 3, 3.
0.0359.
Okay. Now, what's the opposite of none like the plan?
1 minus 6.
No. What is the just in words? What's the opposite of none like the plan?
At least one.
At least one likes it. And isn't that exactly the same thing I'm saying on part C? What's the probability at least one liked it? 1 minus that. Please understand. It's the same thing as rain and not rain. It's exactly the same thing. So what's part C asking? Probability at least one likes. That's like the probability of rain. This is not rain. One is 1 minus the other one. Period. So anytime the opposite probability is easier to calculate, I'm going to do that. Do 1 minus. Calculating this directly would so desperately suck. If I have 3 people, 1, 2, 3, how many ways could at least one of them like something? Well, you could like it, or you could like it, or you could like it, or you two could like it, or you two could like it, or you screw that shit. I'd have to do a calculation for each of those situations. I'd rather do the opposite, because the opposite is none of them like it, and I've already got that shit done. There was only one way for that to happen. And so, just do 1 minus 0.0359. There's a trick. I know you guys have calculators. All right? I don't need to hear smart ass. I'll just use my calculator. But to do 1 minus some decimal like this, what makes this 9? 9. What makes this 9? 6. What makes this 9? 4. What makes this 10? 1. It's going to happen so much in this class. It's kind of nice to know that. Or, that's fine. All right. That at least one idea is going to come up repeatedly because it's a very important idea. Like if I'm quality testing some batch of stuff, I'm going to throw it out. If I find at least one defect, what's the probability of that? Okay, I can calculate the probability of none. 1 minus that, I've got. Because if I got 18 billion things, there's probably at least one of them is defective. Oh, I don't want to do that shit. Could be 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9 or up to 18 billion, whatever the shit. I'd rather do none. There's only one way for that to happen. None of them. Much easier way to calculate stuff. Okay. Anything else from there? Let me go ahead and give you guys the answer key. Let's see what that does. So if you didn't try this double quiz, probably don't even want to look at this thing because it's just going to build false confidence as you agree with what I did. Try to save you from yourself a little bit. Dude! Yeah, a few semesters ago, that's Matt Jeff was doing good stuff. a minute to look at that. See if anybody has any more questions. We'll get into some new stuff.
Could we do a 30, or you show us how to start 36 on the homework? It has something to do with the books on the shelf.
Oh, yeah. Yeah. All right. So, shelf holds 12 books, 8 are fiction or story. Each is a different book with a unique title. You don't know what the title is, but you wouldn't just say that there's fiction and nonfiction and that's it. You would say, for example, there's 8 fiction books. So there's fiction book number 1. Fiction book. Okay, that's all I'll say. Maybe that would be the sample space. Yeah. By the way, if you haven't read the book or looked up words in the book, sample space means the collection of all the things that could happen. So if I roll a die, the sample space is 1, 2, 3, 4, 5, 6. Normal die, not Dungeons and Dragons die or something. Yes, you guys with me?
So with that math question, where I was having a hard time too, you want us just to list every possible thing or figure it out?
Yeah, but it's not, I mean, what could it, you're going to pick one book.
Right.
So what could you get? You can get the first fiction book, or the second fiction book, or the third fiction
They're
book.
independent, correct?
So there are 12 things that could happen. It's not a big deal. If I was picking 7 books, and I said list everything that could happen, then you could
Okay,
be
I was
upset.
making it harder than I had.
Yes. I'm only picking one book. Yeah. So just for example, if I had the numbers 1 through 8 in a hat, and I pick one thing, what could happen? Pick one number, what could happen? 1 through 8. If I pick 2 numbers, picked it and put it back in. So with replacement, what could happen? Get a 1 or a 1, a 1 and then a 2, a 1 and then a 3, and then a 2 and then a 1. I mean, then the minute you start taking multiple things, the sample space gets stupid big. So thank God they just said one book. Right? Okay, anything else from chapter 3? Everybody is fully aware that Wednesday is the double quiz on chapter 3 probability. Okay. Says it on the homework sheet. I've talked about it before, but somebody's going to come surprised on Wednesday. Oh well. Surprise! Okay. All right, if there's no more questions, we're going to get into chapter 4. All right, and just to warn you, as I often do, let me stop and restart this thing. Shoop.